Today, the construction and operation of buildings causes almost 40% of the world's CO2 emissions. By 2060, the number of buildings worldwide is expected to double, increasing energy consumption and associated emissions. To reduce our impact on the environment, and ensure our quality of life, we need to change the way we design and build our urban environment. Building the future. Socioeconomic and environmental benefits can be achieved throughout the building's life cycle. To do so, it is necessary to develop integrated design processes, quality control, and energy efficiency measures, starting early in the design phase. Today's building designs prioritize economic savings in construction, which generates very high operating costs. At the design stage, there is a great potential for energy savings that can be achieved with little or no need to increase the initial investment, but significantly reducing long-term operating costs. But where should we start? We will show you 3 basic steps you should consider to maximize the energy efficiency of a building. 1. Avoid high energy demand by designing buildings adapted to the local climate. 2. Shift to renewable energy sources, thermal storage and district cooling to reduce the carbon footprint. 3. Improve energy efficiency with highly efficient systems and appliances. Avoid. Buildings exist within a dynamic environment. Observe, study and understand your environment. Analyzing local climate data will help you boost efficiency. Existing buildings, along with native vegetation, can promote shade, reduce overheating, regulate temperature, and function as a sound barrier. The dominant winds can be used for cooling and ventilation. A good orientation takes advantage of both solar radiation and prevailing winds. The shape of the building is key to reduce heat gain and to optimize natural ventilation. A compact shape reduces heat exchange between the interior and exterior, while an elongated shape favors natural ventilation. The use of light and reflective colors and surfaces on the roofs and walls reduces overheating by reflecting solar radiation. Walls with high thermal masses keep cool during the day, and slowly release warmth at night. Lightweight walls with multiple openings provide natural ventilation. Roofs can help regulate temperature if they are built with thermal insulation and reflective paints and finishes. Depending on the climate, they can be massive or lightweight. Green roofs contribute to biodiversity, and also function as thermal and acoustic insulation. The position, size and number of windows, as well as the characteristics of the glass and frames, must respond to the climatic conditions. When choosing materials, prioritize to the use of local alternatives, with low-emission production processes. Some materials can reduce temperature changes. If you choose lightweight materials, prioritize the use of renewable resources. In facades and roofs, the use of high-performance thermal insulation reduces heat transfer and increases the hours of comfort. Bioclimatic architecture and passive design maximize energy performance and comfort, reducing costs and environmental impact. When these principles are applied in the design of the facades, the cooling demand can be reduced by 30 to 50%. Several digital tools are available to simulate and optimize building design and energy performance. These tools help us to visualize the climate data of the site, explore building shape alternatives, know the effect of solar radiation and dominant winds, identify the best location and size of openings and windows, assess the benefits of different solutions for exterior materials and other technologies. In the guide, Digital Solutions for Saving Energy in Buildings, you can find a list of tools that will be useful in the design stage. Shift. The second step for optimizing your building is the shift to renewable energy and, where possible, district heating and cooling systems to cool, ventilate and illuminate the building, heat the water and power other appliances. Photovoltaics on roofs or facades or through remote generation are used to provide electricity. Solar thermal energy uses collector systems that generate savings in gas consumption for water heating. District heating and cooling systems can be smart solutions for improving several buildings in an urban environment. At this stage, you need to simulate and calculate the generation potential of photovoltaic and solar thermal systems, to optimize them according to system specifications, local conditions, orientation and shading. Improve. The third and final step is to give priority to the use of high-performance energy systems and appliances for cooling, lighting and power supply, along with the adoption of automation and control measures. The use of high-efficiency lighting is an easy measure to implement, from which many benefits are obtained. Select highly efficient air conditioning and refrigeration systems, free of environmentally harmful chemicals. Use motion sensors, environmental sensors and remote devices to set comfort parameters and maximize energy efficiency. The use of digital tools to monitor and control devices provides administrators and users with information on energy performance and allows remote control, thus maximizing savings. Ensure the correct execution of all proposed measures in the design, through a good supervision at the construction stage. Only a right implementation can deliver the calculated savings and benefits. The use of virtual reality models can help construction companies explain the project and its details. It can also be useful for prefabrication of construction elements. For the operating phase, we recommend you deliver a digital model to users and administrators, so they can take full advantage of the design benefits. Users can control devices remotely or use artificial intelligence to automate certain processes within the building, identify potential energy leaks, and raise awareness of energy consumption. Implementing the 3 steps, avoid, shift and improve, increases the energy efficiency of the building throughout its entire life cycle. As you see, the solution lies in our hands. For more details, go to www.peeb.build and be part of the change. Together, we can redesign the future.